Hello, Matt Davis here with more homework quiz help. This one is from section 6.1. The taller purple curve shown below has a mean of 0 and a standard deviation of 1. Give your best estimate of the standard deviation of the shorter red curve and round your estimate to 1 decimal place. So just a quick note on this in terms of like having an initial guess. Standard deviation doesn't measure height, even though they talk about the red curve being shorter. What's important actually is that standard deviation measures spread, or that would end up being width. So the red curve is wider than the purple curve, so it's going to have a bigger standard deviation. So if you look at it, maybe it's roughly twice as wide, so it might have a standard deviation about double. But guessing's not the ideal way to do it, and I want to give help, not answers. So instead of looking at this one, we're going to look at a different one down below and try and do this first with a guess, but then we'll move on to more of an algebraic strategy. So same idea here. The purple curve is the standard normal curve and has a mean of 0 and standard deviation of 1, and they want us to figure out the standard deviation of the red curve. And again, it is wider and shorter. So since it looks like it's about half the height, it's probably about twice as wide. So I might come up with an initial guess that maybe sigma is somewhere in the neighborhood of 2. But you only get one shot at this, so having only a guess to go by isn't ideal. So I want to show you how you can use more of an algebraic method to get at it. And while we're at it, we'll be answering the previous question, which is how do you estimate the mean of one of these guys. So looking at the red curve, we want to first figure out where the peak is, and I would say the peak appears to be like somewhere right about here, just a little bit to the right of -2. And we've only numbered the even ones here, but the one in between would be -1. So we're somewhere in between -1 and -2, closer to -2. So maybe the mean is about -1.8. So just doing kind of the best we can with a quick guess. And then the other thing we know is that curves flatten out and disappear about 3 standard deviations away from the mean. So looking at the red curve on the right and thinking about where does it flatten out, that seems to be right about here, just to the left of the dashed line for 4. So that's mu plus 3 sigma. And I would say that's just short of 4, so maybe that's something like 3.9. So once you establish those two things, a guess at the mean and a guess at the flattening out spot, mu plus 3 sigma, you can now use those two together to come up with your guess for sigma. So we substitute in the mu. We take this and we substitute it in for that mu. So I get -1.8 plus 3 sigma is equal to 3.9. And then I add 1.8 to both sides, trying to get the 3 sigma by itself. So then these cancel. And I have 3 sigma is equal to 5.7. And then that 3 is connected to sigma by multiplication, so I divide both sides by 3, which will cause the 3 to cancel on the left. And then on the right, I can just simplify that doing the division, and I get sigma is equal to 1.9. So first thing to note is that's pretty close to the guess that we have up above, so that gives me confidence that it's probably right. And then because of the way this is done, I trust it more, right? It wasn't just a pure guess, like, oh, that's roughly twice as wide. I did the calculations. So that's going to be our answer to this one, and we could enter that into the box. So sigma is 1.9. They did ask us to do 1 decimal place, and they do give you a little bit of margin for error here. So if you do this algebra method, that should get you pretty close, and if you're pretty close, you should get marked correct. So I hope that strategy helps make this less frustrating than it might have been for you. Good luck as you return to the quiz.